Sorry about that. You guys couldn't hear me at home. Okay, so I'll repeat what I said. We're going to try to do some more calculus with the work we did yesterday. We found some nice formulas. Part of this is review as we look to the future, but not all of it is review. But okay, let's actually kind of ask you guys a few questions here. Hopefully you guys can do some of these things here. All right. So, for example, if you guys remember, what if they want you to find the absolute min for the following function? Okay, f of x equals e to the x over x, where x is greater than 0 for positive x values. Okay, now what do you guys really think this means? If you start talking about, usually you have absolute min really over an interval. So I want you guys to note something here. This kind of makes sense to you if they give you, I would say a closed bounded interval. So let's say you have a closed interval, something like this, over AB. Okay? So you guys have had this kind of question in Calculus 1. Okay? But they gave you an interval. And then notice you said, but they did give us an interval here too. And I'll say, yes, they did. But it's not closed and bounded, right? They gave us the interval really from 0 to what? Infinity. Because that's what x is greater than 0 actually means. So I'm just going to kind of remark here, typically there is a process here that you guys would use. Okay, what was it called? Do you guys remember from Calculus 1? I think it's called the closed interval method. Gotta double check. Closed interval method here for finding an absolute max and absolute min. So you had those kind of things, Calculus 1. But anyway, let's actually look at this question here. Okay. Now, if you guys remember, essentially what you have to do when it was back in Calculus 1, you had to find critical values in the interval. Remember that? And so we're going to do the same thing here for this function. So I'm going to remind you guys, well, what would you do in the past, right? Remember, you had to find critical values here. And I think that's absolute min, okay, for this question. And so how did you guys do that? Back when it was a closed interval method, right? You're going to have to take a derivative. But what do you guys notice? You have a numerator. You have a what? Denominator. Is that true? And I'm not even sure. I'm going to do letters here. This is your function, okay? What do you guys remember when you have a function that's a quotient and you have to take a derivative? What do you guys use? Okay. Quotient rule, right? Okay, what is quotient rule? Do you guys remember? Yeah. Yeah, it looks kind of like this here, right? If I take the denominator and I square it, bring the denominator up, take the derivative of the numerator. Okay, and this is going to be that derivative. Now, what else you guys do? Minus what? Yeah, derivative of b times a. Is that true? Right? Isn't this the quotient rule that you guys have to use? Let me move this out of the way. All right, you guys remember this? So if that's the case, what do we do to get this derivative here, f prime? You have to square the denominator, so that's now what? X squared, and you bring the denominator up. You differentiate the numerator, e to the x, minus that e to the x, and you differentiate the denominator now. So I switched again And maybe I'll do it. Yeah, I don't know. I switched it again on you guys. I switched that. Okay. So now it looks a little bit more like what you were doing there. Okay, you guys okay with that? Here's your quotient rule. So then what do you do? What's the derivative of e to the x? What's the derivative of x? 1. Okay. So you end up with x, e to the x, minus e to the x over that x squared. Is that true? All right, this is your derivative. So how are you going to find that critical value? Right? I know they didn't give you a closed bounded interval where you have to find the critical value in that interval. Then you evaluate the function at the critical value, evaluate the function at the endpoints kind of thing. This is a slightly different question. You should be curious. You go, wait a minute, how come they didn't give me that closed bounded interval? There's going to be a reason. You guys will see. I'm going to give you guys a note here. I don't know if I should say note. Recall a few things here. Let's note. Where is your function increasing? Where's that function also what? Decreasing, right? So we're going to kind of essentially look at this. This is really what this is about. When I see this, I already know what's really happening for that question. Here's the deal. So how do you find the, I'm going to say, how do you find the critical value? And then I'm going to keep in mind, when is your function increasing and decreasing? You guys remember from Calculus 1, right? Increasing is when that first derivative is what? Positive. Decreasing was your first derivative is what? Negative. You guys remember that? Okay, clearing out those cobwebs about this function. It's kind of related here. Okay? So you're not done in any way. You haven't found critical values. They can ask you increasing, decreasing. It's all going to be related here. But how do we finish this question? Do you guys know? How do we get those critical values? Right? You're going to have to do some, you're going to have to do really you're going to have to do is this. Here's what you say in my mind for these kind of questions. This is always code for what? Sign analysis on the first derivative. All of these questions. If they ask you a relative max, relative min, this wasn't even a relative max, relative min. They said absolute max, which is a little curious. And you're going to see why that's a bit curious. But if they ask you relative max, relative min, if they ask you increasing, decreasing, those are all what? Code for doing what? Sign analysis on your what? First derivative. Okay, you guys okay with that? You know, my daughter used to come to me and say, Dad, they're asking me this question, relative max, relative min. I say, oh, sign analysis on the first derivative. Oh, relative, increasing, decreasing, sign analysis on the first derivative. This one, they go, hey, absolute min, what? That's odd. We'll see. Okay, let's do sign analysis on that first derivative. Let's see if we understand what's happening, right? But you need that critical value. Where do you get a critical value? If you guys remember from Calculus 1. Yeah, you remember the definition? Critical values happen where? Since it's a review of Calculus 1 with this function. What's the definition of a critical value? I'll put definition. F has a critical value where what? Or when for a number C such that f prime of c equals 0, or f prime of c what? Does not exist. You guys remember this? That's the definition of that critical value. It's associated again with all of these kind of things we're trying to do. So yes, you're going to have to set that numerator here, what? Equal to 0. And you're going to have to set the denominator, what? Equal to 0. Is that true? You guys know what I'm saying? Okay. When you set that numerator equal to 0, though, you get e to the x minus 1 is 0. And then what do you guys say here about this? The product rule, or not the product rule, I take it back. The zero product rule. Zero product rule. If you have a product and it equals 0, what does that mean? Each of the term is what? 0. Okay, you guys okay with that? Each of the terms is 0 here. So this is setting that numerator equal to 0 here. 2 terms. Now, what do you guys know about e to the x equal to 0? I'm going to cross this out. You guys know what I'm going to cross this out? What's the reason? Well, this never happens. Yes, you're right. But it never happens. E to the x is never 0. That function is never 0, so you throw that part out. So even though you have a product here and it equals 0, you know what that really means? That just means that the other term is making it 0. That's 0 when x equals what? 1. So you might say, oh, is this what they're looking for? It is. That's your, by the way, the critical value, okay? But you have another part of that. You have the denominator equal to 0. That's x squared. Now, let's go back and let's think about this here, right? So x squared is 0, and we can solve that. And if x squared is 0, do you guys know what that means? Nope. X squared equal to 0. We're solving for x. That means x is what? Is x 1? No. I mean, there's a couple ways I could do that. Square root formula, maybe, right? Square root of 0 is 0. Plus or minus 0, that just really means like positive 1 times 0. That really means negative 1 times 0. Oh, that means x is 0. That means x is 0. In other words, x equals 0 is another critical value, sort of. Why do I say sort of? Be careful. It's not even a critical value because what did they say? They want x to be just positive, just consider positive values for x. They restricted the domain is what they did. So if they restricted the domain, what did they end up doing? They threw 0 out. Does that make sense? 0's not even here. So the point I'm making is this. When you do sign analysis, okay, this is where people will make a mistake all the time. They don't go back to the fact that they have a restricted domain. You know, they'll say, okay, I'm going to put 0 here. I'm going to put 1. Those are my critical values. This is where the derivative equals 0. This is where the derivative is really undefined or does not exist there, right? And then they do this, and they're just simply ignoring the fact that they threw 0. Well, they're ignoring the restricted domain. So really, even if you did this, just remember, you only have really what? 2 regions. Because they threw this portion out. You guys remember that? That's not even defined. These are the values of x. This is sign analysis on that first derivative. Right? First derivative being e to the x minus 1 over this x squared. So you're going to do sign analysis, ladies and gentlemen. Okay? So don't forget, they restricted your domain. So how do you do the rest of this? We need a test point. What's between 0 and and 1 as a test point. So we use 0.5 as a test point. And then over here is going to be what? 2 as your test point. You guys okay with that? These are test points. Sign analysis on the first derivative. If you plug in 0.5 for x, okay, 0.5, 0.5. 0.5 for x. Sign analysis on that first derivative. Now, what is e to the 0.5? Do you guys know e to the 1/2? I don't know the value, but I know it's positive. Is that right? And what's 1/2 minus 1? Isn't that negative? What's 1/2 squared? Isn't that positive? So here's what I'm saying to you guys. This portion's positive. This portion's negative. This portion's positive. Okay. What's a positive times a negative divided by a positive? Isn't that negative? Region 1 is what? Is that negative? So in other words, if the first derivative is negative, the function's decreasing in that interval. Okay, just to kind of let you guys know. If you test, now this is testing region 1. If you test region 2, what's the value here? Well, it probably is. Let's plug in 2 now, okay? E squared is positive, is that right? And then 2 minus 1 is positive, and 2 squared is positive. So what you're really seeing is, yes, you got a positive term, positive and a positive, and we know that makes this region positive here. And that means the first derivative is positive. You have an increasing slope. Now this makes a lot of sense to me for the question, right? You say, why does that make a lot of sense? I'm going to erase this. Let's finish the analysis here. You see, what you're looking at here, a picture is worth what? 1,000 words. There's a lot of information that you're looking at. Sign analysis on the first derivative gives you a lot of information, right? Let me see. Yes, Joe, and and thank you for reminding me. I'll look into it. You're right. Thank you, Joe. All right, we're looking at a lot of information here. What am I looking at? What can I say about this function? F is what? Right? This really isn't even calculus 2. It's calculus 1. But what am I really saying if I try to get, let's do some of this. See that interval? That interval and that interval here, we're going to look into. F here is what? F is decreasing. What interval is it decreasing on? 0 to 1. F is increasing. Where is F increasing? 1 to infinity. And that's what you're looking at. Because that first derivative is negative in the interval, and the first derivative is positive in the second interval. Why don't I include the endpoints? This is another area where people make mistakes. Why don't you include endpoints on this? You guys know? Well, the derivative does not exist at 0. And the derivative at 1 is actually equal to 0. 0 is not positive, 0 is not negative. Why do I put this here too? Because this is important here. You guys remember? What does that mean? When you have you go from a decreasing slope of that curve to an increasing, right? Decreasing derivative to an increasing, what does that mean? Nope. Where are you standing? Are you standing on a hill or a valley? What does that mean? If you're in a valley, that means F has a what? It's a relative, really, min at x equals 1. That's not the relative min. It has a relative min. And I'm going to say, let's note, what is the relative minimum value? That's really f of 1. So you're going to have to know what f is. What is f? They gave it to you. So you plug in a 1 and a 1. You say, is that e to the 1 over 1 or just e? It's just e. So the relative minimum value, ladies and gentlemen, is equal to what? E. Okay? So that's generally how you answer this particular question. Okay? This is all the analysis that you get on that first derivative. But then you go back to the question, you go, but Mr. Judge, they didn't ask me that. They want to know absolute minimum value. And I'll say, yeah, I guess you're right. It's kind of it's not a relative min, it's an absolute min. So why can we make that distinction? How do you guys know, just by looking at this, that this is really not a relative min? It is, but it's really also an absolute min. Anybody know why? Because this interval is going on where? Forever. Is that right? So that curve is increasing forever. It came down, and at 1, it bounced back up. So the relative min becomes really an absolute min. So the actual language of the question is exact. So just kind of throw that out. Now, if you said, I don't really believe you, well, let's go to Desmos. And remember, y here equals e to the what? To the x divided by x. Okay, now remember, we had a restricted domain. What do we do with this domain? This is really the curve if you included negative values. But we restrict, and there's a way to restrict the domain. I believe it's going to be, let me go find it here. Let me see. Is it going to be, I think it's going to be x greater than 0. Yeah, there we go. I restricted the domain. So isn't it true that the curve is, in this case here, you don't even have 0 in the domain. You restricted it. That's good. But you have a vertical asymptote there. But what are you doing here? Do you guys know? At x is 1. Could you guys see that there? 1, y is e. You're standing in a valley. That's a relative min. But in this case, it's an absolute minimum value because there's no other minimum value. That's what makes it an absolute. So the question is actually correct. But e is about 2.718. Is that true? And then this thing increases what? Forever. Okay, you guys okay with that? Just clearing out the cobwebs from calculus what? 1. And then looking at the picture, could you guys tell me anything more? Just looking at the picture. I know they didn't ask this question, but I guess they could. On that interval, positive values, where is it concave up? Concave up. Oh, I'm glad we're clearing out the cobwebs. Was it a long winter? Do you guys know what I mean? Mr. Judge, that was a long winter. Did you take Calculus 1 during the winter? Anybody take Calculus 1 in the winter? Raise your hand high and proud. No? Because then that means you guys should remember concavity. Is that right? Because you just had it 2 weeks ago. Or 3 weeks ago. Okay. Am I right? Maybe 2 or 3 weeks ago. You had it 3 weeks ago. If you took it during the winter. Anybody take it in the winter? I'll check. I'll check online right now. I'll find who it is. We'll ask you. I don't have access to that. How do you find where it's concave up? Yeah. So remember, concavity, generally speaking, just to bring that up too, calculus here. Concavity, I would tell you guys, just think always sine what? Analysis on your what? Second derivative. So I have the first derivative. What was that first derivative? I think it was e to the x minus 1 over what? X squared. I don't even know if I want to do the concavity question. Man. I don't think I want to do concavity. Should we? I guess so. Right? Should we try that out? All right. Quotient rule again, is that right? X to the fourth power. Or, if you rather, take x squared and square it. Bring up your what? X squared. Now, differentiate your what? Numerator. E to the x minus 1 minus e to the x minus 1, derivative of the denominator. And like I said, I'm not even sure if I want to do this, but I will. I don't even remember if, well, whatever. You always have to be careful, ladies and gentlemen. If you start trying to do calculus on any function you see, you may not be able to do the, there might be issues. Let's do this. Okay. So what I'm going to say this, well, let's kind of go back. There we go. This here is easy to do. That's simply what? 2x. Your work is really going to be where? Here. This portion, there's no derivative. That's x to the fourth. So if I said to you dx e to the x minus 1, what do you guys use here? Product rule. Okay. So you're going to have to use product rule here. E dx times x minus 1 times e to the x. So this is x e to the x plus x e to the x minus e to the x. I'm going to distribute there. So there's going to be some work here. Let's put it all together. X squared times x e to the x plus x, well, plus 2x e to the x. Minus e to the x. Minus here, x e to the x. Well, let me be very careful now. And that's 2x. So I'm going to do this. Minus e to the x minus 1 times what? Times 2x. Okay, so this will be, let's do some arithmetic here. 2x cubed e to the x minus x squared e to the x. I'm going to put minus 2x e to the x minus 1 over what? X to the fourth. 2x cubed e to the x minus x squared e to the x minus 2x squared e to the x minus 2x e to the x all over x to the fourth. Is that right? So what do you guys notice here? Is there anything we can do here with this? Well, I'm going to say 2x cubed here, e to the x. I'm going to combine my terms. Is that minus 3? X squared e to the x? Double check. then minus 2x e to the x. Is that right? Over x to the fourth. Double check. What could you factor out? What's common here? Hope I didn't. Did I miss add here? Double check, ladies and gentlemen. I can see 2x e to the x, x minus 1, 2x squared e to the x. I think this is plus, right? You guys okay with that? Anyway, so it looks like I have what? Let's see if hopefully I didn't make an arithmetic error. So I can factor out a what? Looks like it's x e to the x. Now we have what? 2x what? Squared minus 3x plus 2 over what? X to the fourth. Double check, ladies and gentlemen. Yeah. I think so. Yeah, I was looking at that. I was trying to find it. Yeah. The derivative of what? Oh, did I skip that one? Where are we at? E to the... Oh, the first one. Sorry about that. I'm thinking of something else. Okay. Oh, thank you. That's now it's going to be a little bit better. All right. So let's double check. X e to the x minus e to the x. Okay, that's going to be a lot better. Because this is gone. Is that true? Okay. E to the x plus... Okay, it's a lot better now. So this is going to be here, what? Is that x e to the x? All right. So let's get rid of this here. All right. Okay. All right, we got what? X cubed e to the x minus, I'll still do this, 2x e to the x, x minus 1, x cubed e to the x. That's going to now be what? Plus 2x squared e to the x minus 2x e to the x. Okay. Let's double check. And it might be plus. Is that right? Let me double check here. Okay. Here we go. So minus the 2x squared plus. Double check there. Minus 2x squared e to the x plus 2x e to the x. Okay. Can we factor anything out here? Can we combine any terms? What do we get? Factor out the x, e to the x, and what do you have left? X squared minus what? Is that minus 2x? Plus what? 2. Is that true? Something else is wrong here. So we got x cubed e to the x minus the 2x squared e to the x plus 2x e to the x. So we make sure it's minus and then plus. Okay. So let's double check. X cubed e to the x minus 2x squared e to the x plus 2x e to the x. And we factor out the x e to the x. X squared minus 2x plus 2. Okay. Anyway, let's double check here. So what's going to happen here? Do you guys know? You have that cancel. So what do you have left? E to the x. X squared minus 2x plus the 2. And now this is power what? 3. And there's something bothering me about this. Something's wrong. Something's wrong here. Okay. So we got e to the x, x minus 1 plus x minus 1 e to the x. Let's double check. E to the x. Okay, e to the x plus x e to the x minus e to the x. Yes, that'll just be x e to the x. So we do have x squared e to the x minus e to the x minus 1 times 2x. That will be x cubed e to the x minus 2x squared e to the x plus 2x e to the x. Okay, we look like we're okay here. Anyway, we might be okay. All right, now here's the deal. This is your second derivative. Double check. X e to the x comes out. Okay, so it looks like we're okay for the second derivative. So let's put that here. Right, you guys good with that? All right, now what do you guys do? You say, what about the sign analysis portion? Okay, so for the sign analysis, remember now you have a numerator again and you have a denominator. You set them both equal to 0, right? Numerator, denominator. So if I set the numerator equal to 0, we have e to the x squared minus 2x plus 2 is 0, and then we have the x cubed is what? 0. So let's put it together here. This portion here. And then you have this portion. So the bottom says x is what? 0. But you throw it out. You say, what do I throw it out? It's not even in the domain. Function is not defined. So, okay. Now, what about the numerator? You say, this means e to the x is 0. Never happens. X squared minus 2x plus 2 what equals 0? This never happens. Okay, you guys okay with that? So what about this x squared minus 2x plus 2 is 0? What do we do with this? Well, I don't think it's factorable. Is that right? I think it's 2x. So I don't think you could do what with that? You're going to have to use what? Quadratic formula. Okay. So x equals negative b plus or minus square root b squared minus 4ac everything over 2a. So a is 1, b is negative 2, and c is positive 2. So negative 2 plus or minus square root negative 2 squared minus 4 times 1 times 2. Everything over 2 times 1. So x will be 2 plus or minus square root 4 minus 8. Is that right? Over 2. Now, what do you guys notice about this? What does this give you? Complex what? Solutions. Is that true? Double check. Negative 2 squared is positive 4 minus 4 times 1 times 2. This gives you complex solutions. So wait a minute. So far, if you had to do sign analysis, okay, you have that 0, and that 0 does what? This is region 1, and this is region 2. Is that true? But you threw this portion out because x is positive. They only say focus on the positive values. What does that mean, ladies and gentlemen? You know what that means? Pick any number in region 2. You can say 1. You can say 2. You can say 3. Say 3? But you're doing sign analysis on what? This derivative. So if you plug in 3 wherever there's an x, isn't e to the third, I don't care the value, isn't that positive? Isn't 3 to the third positive? I don't really care. But what's 3 squared minus 6 plus 2? 9 minus 6 is what? 3. 3 plus 2 is what? What does that mean about region 2 or whatever that region is? Positive times a positive is positive. So here's what this means. So when you do sign analysis on the what? On the second derivative, that region is positive. And what do? This is your concave up picture. So the answer to the question is, what about concavity? The function is what? Concave up, CU. On what interval? 0 to infinity. Where is it concave down? F is what? Never what? Concave down. Why is it never concave down? Second derivative is never negative. It's always positive. Are there any inflection points? Do you guys remember what an inflection point is? There's no inflection points. Why is there no inflection points? Inflection points happen on points in the curve where you change concavity from up to down or down to up. So since you don't have two types of, if you don't have concave down anywhere, you'll have no what? Inflection points. So I apologize for that error at first, and then you go, oh my God. So here's what I'm saying to you. Just beware. I want you guys to have this be something in your head as well, right? A lot of times, these questions are specially chosen. So if they say to you, hey, find the absolute min or max of a function, that's what they want you to do. Going further and trying to find like even concavity, it might be that this problem wasn't chosen to find concavity type of thing. You guys know what I mean? So you got to always be careful about that. Don't just pick any function and try to do all the analysis in the world because you might have an issue. This one is not that big of an issue. However, it does require what? Knowledge of, where was it that? Knowledge of the quadratic formula. So sometimes that does happen. And, it's a pretty good, knowledgeable question. You go, what do I do when I get complex solutions? Well, that means you throw that portion out, really. It's not going to contribute to finding what? The value. Just like e to the x is never 0. Well, this thing is also what? Never 0. Only the denominator is what? 0. So you're still doing sign analysis, and that's why we did this 0 here. Second derivative is not defined there, but you guys knew that already, because when you look at Desmos, what do you guys see? You actually see the exact picture, that this curve holds water from 0 to what? Infinity, but you don't include 0. 0 is not even there. But they told you from the beginning, don't include 0. X is greater than 0. So, yes, does that look to you like it holds water? Do you guys remember, where are the people that took Calculus 1 in winter, right? Remember curve sketching guidelines? Didn't you have holding water, that holds water? Concave up? You guys see what I'm saying? Holds water. What is concave down? Okay, you can call it umbrella. It does not hold water. Okay. What's an inflection point? Changes what? Concavity? Yeah. So this is kind of this is a good one, ladies and gentlemen, by the way. That's pretty good. Anyway. All right. Oh, you say, what about this one? Should have you guys try this one? What if they gave you this function? F of x equals x squared e to the x. Find where f is what? Increasing and what? Decreasing. And actually, this question has more. They also want you to find intervals of what? Concavity. So this one might be chosen so that this is a good concavity question as well. Interval of concavity. So you guys already know. What do you guys use to get that derivative? What rule do you guys use? Product rule. Okay, so I would recommend you guys do that. So here's my product rule. Right. Did we do this one yesterday? Oh, I think we did. Okay. So intervals of increasing, decreasing. What do we say that was? Sign what? Sign analysis. What about intervals of concavity? Sign what? Analysis on what? Second derivative. So if we're going to do sign analysis on this function, we have to set it equal to 0, right? Essentially, you're finding critical values. So this will be what? E to the x. Actually, it's not. It's x e to the x. Let's write this a lot better. X e to the x. So this will be what? X plus 2, I believe. Okay, 0 product rule. Actually, there's how many terms here as a product? Do you guys see it? You can say this term, and then what? This term. So it's kind of the generalization of the product rule. This means x is 0. This means e to the x is what? 0. And this means what? X plus 2 is what? 0, right? Okay, so if we see the 0 product rule in general. So this is already done right here. E to the x, what do we know? Never what? Happens. You throw it out. It actually happens, but not for real numbers. That's a whole other story. Sorry. Just like, and I want to say that it happens for complex solutions, but it does not happen for real numbers. Just like the last example had a complex solution, you throw it out. You guys see what I'm saying? So I just want to kind of say that to you guys. There is a solution there, but it's not real. You got to take other math courses to find that out. This does happen, right? X is what? -2. So I kind of want to present that to you guys in a complete way, because now sign analysis, right? You got the real number line again, okay? At -2, at 0, that first derivative, there's 0 here. So you got 3 regions here. Because remember, region 1, 2, and 3. Okay, did they restrict your domain in this question? Nope, no restriction. So in sign analysis, give a test point in region 1. What do you guys think? Well, be careful. Has to be to the left of -2. You can say -3. If you want to be safe, you can say -5, right? There's your test point. A number in region 2, -1 could be used here. Then a number in region, what, 3, anything to the right of 0, maybe 3, okay? So I want you guys to know you're testing the signs on the first what? Derivative, okay? And your first derivative is where? Where is that first derivative at? I got to find it again. Right here. It's x, e to the x, x plus 2. So when you plug in the first test point, right? -5 here, -5 here, -5 here. What's the deal? What do you get? Well, negative e to the -5 is really a what? That's a positive number. Is that right? Because you say e to the -5. Well, that's 1 over e to the 5th power. It's positive. And what's -5 plus 2? Isn't that -3? So what's my point? Region 1's positive. That's the whole point. Because you got a negative times a positive times a negative. Okay? Okay, let's try this other one. -1 now. -1. Okay. So you say, what is that? Well, a negative times a positive again, because this is 1 over e, right? What's -1 plus 2? And that's positive. So what's a negative times a positive times a positive? Region 2 is negative. All right. Next test point. 3. Now, 3 is positive. E to the 3 is also what? Positive. And 3 plus 2 is positive. So you got positive times a positive times a positive gives you a? Region 3 is positive, ladies and gentlemen. Okay. So you have all kinds of nice information here. It's nice. But what's the conclusion about the function now? What do we say here? Do you guys know? Nope, this is first derivative. Positive first derivative says what? This is what your tangent is positive, increasing slope negative, positive. Right? First derivative. What does it mean if you're standing right here? You're on top of a hill. What does that mean? Relative max. What does it mean if you're in a valley? Relative min. Clearing out the cobwebs. You guys remember that? Okay, let's do some conclusions here, because you got a lot of information. This picture is worth 1,000 words. We can say f, your function is what? Increasing on what intervals? Negative infinity up to -2. Okay, region 1. This is how we describe region 1. But also, union 0 to what? Infinity. Why do I say that? We're describing what? This interval united with this interval. And let's put arrows. Because those things are going forever in those direction, right? This is where your function is what? Increasing. It is decreasing if we find it's decreasing in region what, 2? So what is region 2 now? You're going to say that. You say what? F is what? F is decreasing on what interval? -2 to 0. What can we say? F, what's the relative max? The relative max of this function is equal to f of what number? See what you guys think. What is it? F of what? Where do you have a relative max? At what? At -2? But that's not the relative max, so be careful. It happens at -2. You're going to have to find the value of that function. Where do you have a relative min here? F of what? Go over here. F of? Is that f of 0? f of 0, ladies and gentlemen. But that's not the relative min. It happens at those locations. So this picture is worth 1,000 words. You got to go back to the original function. So, you know, if you say, what is f of 0, by the way? Right? That's going to be 0 times 1, which is 0. So this one equals 0. Negative 2, we can plug in negative 2 now. Now, negative 2 squared times e to the negative 2, that's 4 over e what squared. So 4 over e squared, this is the answer for the relative what? Max. And then relative min, like I said here, f of 0 is 0. All of that information from your what? First what? Derivative. That's what you guys have in Calculus 1. Right? First derivative. You guys take that in where? Where did you guys take it? Anybody take it in high school? Did they do this in high school? Hopefully. You guys know what I'm saying? Okay. What about concavity? Because what's this curve here? What's the original curve? X squared e to the x, right? So if I share with you guys in Desmos, y equals what? X squared, exponential function. Where are you, exponential function? There we go. E to the, well, it's kind of a weird thing. I think it does have e. Okay. Okay, so we're really looking at this curve here. At negative 2, yes, you're on top of a what? Are you on top of a local hill, local max, relative max? And then here you're at a what? Local min at 0. It's probably going to be an absolute min though, because it's the smallest value. The local max is not an absolute max because, as you guys can see, that curve goes up forever. What about concavity? Can you guys see anything about concavity? At some point, you go from an umbrella to not holding water to what? Somewhere in the middle there, in this interval from negative 2 to 0, so you guys know. Probably at negative 1, maybe. But don't eyeball it. Don't do that. You know, I know that in high school, you know, it's crazy. They'll say, use your TI and touch it, and you find it, and there's your answer. Like, really? I hate to say it. You go, they have you guys do that kind of stuff? Yeah, exactly. You guys don't get me started on that one. Good. Then she earned her pay. Or he earned his pay. What about concavity? Second derivative, right? Second derivative, sign analysis on the second derivative. Okay, so here's what I'm going to say. So you go, how would you do that? Well, think of it this way. First function, and then what? Second function. So pull out the first function. Differentiate the what? Second. Pull out the second function. Differentiate the what? First. So this here will be 1, but this one, product rule. Is that right? X. We know this derivative is what? E to the x, and this one is 1. So that portion here Let's try to put it all together here. We're talking about what here? This. Is that right? So what is that? That's going to be x e to the x plus e to the x. Double check, ladies and gentlemen. So let's write down that second derivative now. X e to the x plus 2 times x e to the x plus that e to the x. So x e to the x plus, let's be careful, x squared e to the x plus 2x e to the x plus e to the x there. Is that true? Double check here. X squared e to the x. Oh, hold on. What did I do? Nope, there's more to the story. Hold on. All right, double check here. X squared. Okay, here's what we're going to do. That's going to be x squared e to the x plus x e to the x. Okay, plus what? 2x e to the x plus 2 e to the x. Okay. All right, you guys okay with that? And so now, let me remark here. X e to the x, x e to the x, 2x e to the x. Those are like, is that right? So I'm going to leave this x squared e to the x plus, is that 4x e to the x? Double check. Plus 2e to the x. So, looks like this is going to be the second derivative. Double check my arithmetic, ladies and gentlemen. Come on. But, I'm just going to highlight it. But if you have to do sign analysis on it, you do. What do you think you're going to have to factor out? And then hopefully what you have here is what? Is factorable. Okay, because when you do sign analysis, on that second derivative, you got to set that second derivative equal to 0 and solve for x. Is that right? So you say e to the x, x squared plus 4x plus 2 equals 0. And then what do you guys do with this? E to the x is 0. X squared plus 4x plus 2 equals 0. And ladies and gentlemen, what do you know about the left side? Never what happens. If it never happens, you get to throw it out. And what about the right side? What do you guys know about this? Is it factorable? Nope. Then what do you use? The quadratic formula. Hopefully you don't get imaginary what? Numbers. Is that true? What do you get? You guys know? X equals negative b plus or minus square root of b squared minus 4 times 1 times 2. Everything over 2 times 1. By your quadratic formula, negative 4 plus or minus square root of 16 minus 8. Okay. Over 2. So x will be negative 4 plus or minus square root of 8 over what? 2. So x is negative 4 plus or minus. You guys know what that'll be? Isn't that 2 square root of 2? That's 2 square root of 2 over 2. So x is going to be negative 2 plus or minus the square root of 2. And that's x is negative 2 plus the square root of 2. X is negative 2 minus the square root of 2. Is that true? So these are all what? Let's find out what that is. I'm going to approximate these here. -2 plus the square root of 2. I'm going to go to the tenths. -0.6. And this will be -2 now minus the what? Square root of 2. -3.4. Okay. So, just to kind of help set you guys up for this, for your sign analysis, okay? What do you have first? It looks like you're going to have 2 points here, right? -0.6, -3.4 here. Second derivative is 0, ladies and gentlemen. Region 1, 2, and what? 3. What you'll do is use test points. If 0 is available, use 0. -1's available, okay, good. And then -4 is available, right? You can let your life be, hopefully, what? Easier. And this is on what derivative? You can make sure it's on the second derivative. So, you plug that in the second derivative, wherever the second, this whole thing. I got news for you guys. This first term of e to the x, always going to be positive. Is that true? Doesn't matter what value of x you use here for e to the x. It'll change for x squared plus 4x plus 2. So, I mean, like, for example, -4, isn't that 16 minus 16? So I can actually, you can do this mentally. This is positive. -1, you're ignoring that e to the x because that's always positive. So -1 squared, 1 minus 4, -3. -3 plus 2, that's negative. And then positive, what's the other value? 0. Oh, that's easiest. It's just a 2. Okay. So you guys have all the information about concave up, concave down. Nice. Let's finish this. F is concave up on what interval? -infinity up to, you can use the numerical approximation. Okay. And then, or you could use the exact value. Your book might have the exact value. -0.6 up to infinity. F is what? Concave down on what? The interval from -3.4 up to -0.6. You can use the approximation. Does it have inflection points? Say yes. Where are your inflection points? Why? Because remember concavity, right? This what? What is that symbol for the secondary? This holds water. This is your umbrella. This holds water. Concave up, concave down. So inflection points, if you guys remember from Calculus 1, they happen at -3.4, comma, f a -3.4, and the other one is at -0.6. You're looking at the picture. And f a -0.6. You guys can use the the symbolic values or the decimals. Inflection, inflection. And that's the analysis that you do on the second derivative from Calculus 1. But now it's involving the exponential function. So ladies and gentlemen, double check. I do think we're good. Remember, this picture's worth 1,000 words. I took some extra time. But that should actually do what? That should actually start to help you with like homework 1. Okay? Question starting at like 7.2 in your book. And then Joe, I also, yes, I'll try to look it over, Joe. So if Joe Leone is still there, I did get your email. I just haven't had a chance to look at that, but I'll try to find and correct that issue. It's on my list. So anyway, yeah, Joel's responding about something down here. No, maybe not. I'll double check your email, Joe. Okay, so you guys able to do some of these questions here, by the way. We just started working with derivatives, clearing out the cobwebs. We got to do some integrals. You guys know what I'm saying? So, okay, take a look at some of that, and we'll see you guys when? On Monday, okay? Take care and stay safe.